Okay, this is the last video. This video covers 10.3, surface area and volume. Now, I want to recall to you that on the formula sheet, there are specific formulas for these. Now, the capital B we'll talk about is the area at the base. The L in surface area is the slant height. And we'll go through these now. And I say that this is the formula sheet for the final. I may change this up. If I do, it'll be posted. The formula sheet will be posted on the website. There, you need to be able to describe where each of these formulas come from. We've already gone through the area formulas. Now we're going to go through surface area and volume. There are a couple that the method in which you use to come up with their area is beyond, or their formula is beyond the scope of this class, and that is for the sphere, the volume, and the surface area. Those come from calculus, and we do not assume that you know calculus in this course. If you are studying for middle school math, then you will have to have a calculus class at one point. And we'll talk about those formulas in that course. So at this point, they will be given to you. You will not have to tell where they come from because they do come from material beyond the scope of this course. All right, so let's get down to it. The surface area is the area of all the faces. So think about the area needed to cover all the faces of a three-dimensional object. So if I wanted to wrap, this is a 3x5 card box. If I wanted to wrap this as a gift for one of my kids, or as a graduation present, then the surface area would be the amount of material, the amount of paper that it would take to wrap this. Say that I wanted to make Christmas ornaments and I wanted to paint, say that this was enclosed. It's not, it's a toilet paper roll, so it's not enclosed, but say that I wanted to enclose it and make it into look like a Christmas ornament that looks like a piece of candy to hang on the Christmas tree. Then the surface area would be the amount of material that I need to enclose it, excluding the little tails at the end of the piece of candy. And we'll talk about how to find all of these formulas in this course, in this section. We will also even talk about how to find the surface area to wrap this truncated dodecahedron, which is also a soccer ball, okay? And so we'll talk about the formulas of how to do all of these and more. But I wanted to give you some ideas, and we'll come back with our props as we get through this material. An Ingon prism. So this is an Ingon prism, right? It's a rectangular prism. Each face, if I look at this as the face of the front, as this side, and the back as this side, and then all the other sides are rectangles. So how would I find the surface area? Well, it's the area of the base. So the area of this rectangle is length times width, right? But then I have two of them that are exactly the same. Then I have these two are exactly the same. And then I have these two. The ends are exactly the same. So I would find the area of each of those rectangles and add it up. In general, if I have an Ingon prism, then I'm going to find the area of the Ingon, and the way I do that is I find the altitude, the side length, and this is the height of the prism. So the area of the base is going to be 1/2, because it's triangle, times the number of sides, times the altitude, times the side length. So that's 1/2 the area of the triangle, and I have 6 of those triangles in this case, so the number of sides, and that gives me the area of the base. For the surface area, I have 2 bases, so that's 2 times the area of the base, plus n times the area of the side, right? N being the number of sides. So in this particular case, it's 2 times 1/2 6a times s, plus the area of the side is going to be s, the side length, times the height, because in a prism, all of those sides are rectangles. That is definition of prism, is that those sides are rectangles. In this case, I have 6 sides, and so it's going to be 6sh. Okay, and that's just the general form for this particular prism. Now, we will do specific examples with measurements in the end. All right, the next figure we want to look at is a cylinder. Okay, so what we're going to do is we're going to take our toilet paper roll. Okay, and now remember that each of these ends is a circle, correct? And so what is the area of the base, or the ends? The area of the base is pi r squared, and I have 2 of those. So for my general surface area formula, I have 2 times pi r squared. Okay? Plus, again, the area of the side. The area of the side, or the lateral face. The side is the lateral face. Now, how do I find that out? Well, I'm going to take this toilet paper roll, and I'm going to cut it. Okay? And unroll it. And what shape do I have now? I have a rectangle. Okay? So the distance along this side is the height of the cylinder. All right? So I'm going to have the height of the cylinder. Remember, I have a rectangle. What is the distance of this side? Well, I can roll it up. So what is it? It is the circumference. So it's 2 pi r. All right? So it's the height times 2 pi r gives me the area of the lateral face. So that is 2 pi r h. And so that is the general formula for a surface area of a cylinder. All right, next we have a pyramid. And before I started this lecture, I tried to go through the house and see if I could find objects within the house that fit these so that I could explain them a little easier, which is why we had the toilet paper roll. And I could not find a pyramid just off the bat. Now, I thought I do have, maybe I don't. They're at Tech. My platonic solids are at Tech, so I don't even have those. So how would I do a pyramid? Well, what you're going to do is you're going to flatten the pyramid out. And so for the surface area, for the general surface area, you're going to have the area of the base. And we label that with a capital B. So on the formula sheet, that will be a capital B, will be the area of a base. In our particular case here, we're going to do that base as a square. So the area of this base is s squared. Now, we talk about the area of the lateral face. So the area of the face. That lateral face is a triangle, right? It's a triangle. But that triangle is going to be at an angle, right? And so we're not going to use the height of the pyramid, so the height down, so my scissor height, we're not going to use that height to find the area of that triangle. We're going to think about laying that triangle flat, and we're going to use what we call the slant height. So L is the slant height. And that actually should be a scripty L, not just an L, and that is a special mass symbol, and it's ELL is the special mass symbol. So the area of the lateral face is going to be 1/2 the base, which is S, times the height, which is the slant height. So our general formula is going to be 1/2 SL. Now, I have to sneeze. Sorry. Excuse me. Now, in general, we say 1/2 SL, but it actually, this is wrong. You have to put in. You have to put the number of sides that you have. So this is going to be, in this case, it's going to be times 4. Okay? And so because I have 4 triangles, right? I don't just have one triangle, I have 4 of them. So I have to multiply by the number of sides. So this should actually be times n. And so that will be, you need to make sure that you remember that it's not just times SL, it's times however many of those triangles you have, right? Okay, cone. Again, I went through the house looking for a cone, and I didn't even have an ice cream cone. I probably have a cone in my crafting stuff, but that would be digging it out. Let's talk about a cone. Now, a cone is similar to a cylinder in that the base, the area of the base is always going to be a circle, so the area of the base is going to be pi r squared. For the lateral face, for the face of a cone, you're going to open it up. All right, and the distance across the bottom here is going to be 2 pi r, because you're going to cut up the side and you're going to spread that thing out. Okay, so imagine, got a cone. Okay, I'm going to take this, I promise I'm going to make one real quick. It's going to take me just a second. All right. Yikes. And can't cut straight when I'm in a hurry. So imagine that I have a cone. Okay? And I'm going to take the cone, and my sheet of paper is too small. Okay? A cone, a funnel. Okay? If I take this and I open it up, basically I have a triangle. Right? Well, the height of this triangle is not the height of the cone. Right? Because the height of the cone is going to be wrapped around. Okay? Imagine joining those sides. The height of the cone is the vertical height from the tip down to the center of the circle. So it's, imagine dropping a height through the tip and it's going to go straight to the center of that circle. But that's not the case with a cone, because if I open it up, I have these little tails, right, to make it round. And so the height of this triangle is not the height of the cone. So what we're going to look at is the lateral height. So we're going to look at how much the height of this triangle is. If I draw, I want to know this distance. That's going to tell me the height of the triangle. So this distance is L, is that slant height. Okay? And the way that I find the slant height is the Pythagorean theorem with the height of the cone and the radius of the circle. So then the area of the face of the lateral face is going to again be 1/2. The base is 2 pi r times the slant height is the height of the triangle when I open it up. Okay, and so that gives me pi r L. And so my surface area is going to be pi r squared plus pi r L, where that L is the slant height. Okay, and that's a cone. Now the next figure we're going to talk about is a sphere. And in order to find the area of a sphere, the surface area of a sphere, of how to wrap a ball, and I do have balls all over our house, but in order to wrap a ball, you have to use calculus. And so this formula is given to you on the formula sheet, and it is 4 pi r squared. Okay? And that will be given to you on the formula sheet, and it's just what I like to call a plug and chug formula. Okay? Where r is the radius of the sphere. Okay? So r is that radius of how far it goes again. That is all the surface area, so now let's move on to volume. Volume talks about how much it would take to fill up the object. So if I wanted to figure out, surface area talks about how much it would take to wrap this object. Okay, so that's surface area. So surface area talks about how much it's going to take for me to put wrapping paper around this object. Volume is going to talk about how much it's going to take me if I wanted to fill this up with liquid or some sort of fluid or something. That's going to be the volume. It's going to be how much it takes to fill up the object. Now, the way that we find the volume is, what we do is we take it, so I took these 3x5 cards out of my box, and basically my volume is going to be how many 3x5 cards can I fit in there. Does that make sense? It's going to be how many 3x5 cards I can fit inside. Well, Cavalieri's principle says that if I want to find the volume of an object, all I have to do is find the area of the base and then slice up that object. So, how many 3x5 cards and what is the thickness of it do I have that fit inside my object? So how many slices can I make to fit inside my object? And that is going to tell me the volume. So in other words, if you're trying to find the volume of a prism, you're going to find the area of the base times the height, times how many of those slices, because you're going to say that each slice is part of 8. And so I need to add up those slices. Well, I have 8 slices going up. And so it's going to be length times width times height. So however many slices I can make. So the volume of a rectangular prism is length times width times height. The volume of a general prism is the area of the base, so B times the height, or area of the base times the height. All right? And so if you want to find, I have something that I couldn't dump to get over here. So if I wanted to find, say my Kleenex box is empty. I don't know if you can see it. Say my Kleenex box is empty. So I wanted to find the volume of this Kleenex box. Then I would find the area of the base and multiply by the height. And that would tell me how much I can put in here. Or I could even do it as finding the area of this base and multiplying it by this height. It doesn't matter. For cylinders, so for a cylinder, what we do is this is circular. So what we're going to do is we're going to say, let's slice up this region around the cylinder into rectangles. And we're going to make that, the more slices, the more rectangles I have, the closer and closer I'm going to come to a circle. Okay? And so that's why they have it broken up this way. Another way to think about a cylinder is, like I said, it's the area of the base. So the area of the circle, so your volume is going to be the area of the base times the height. So how many slices I make, that slicing is going to be the height. So what's the area of the base? Well, the base is a circle, so pi r squared times h is the volume of our cylinder. And this is a different way to think about it than this, but if you remember that volume is always the area of the base times the height, then you will never have to memorize these formulas. You will just know, well, I have a cylinder. What's the area of my base? My base is a circle. The area of a circle is pi r squared. What's the height of my cylinder? H. So it's pi r squared h. Now here's the difference. The difference comes in when you have a pyramid. And the neat thing about a pyramid is that if I have a square pyramid, then it takes 3 square pyramids to make a cube. And the area of a cube is s squared. And so the area of these 3 square pyramids will be 1/3, because the area of one pyramid is 1/3 the volume. The volume of one pyramid is going to be 1/3 the volume of the total cube. So it's 1/3 s squared times h, because remember the volume of the pyramid would be s squared is the area of the base. I have s because it's a cube, so I have s slices, so that's s cubed. So the volume of a cube is s cubed. But if 3 pyramids make a cube, then the volume of a square pyramid is going to be 1/3 s cubed. All right? Again, you can think about pyramids as 3 pyramids make a prism. Okay? So if I have an hexagonal pyramid, then 3 pyramids will make a hexagonal prism. Now, the geometry or the way to cut the shapes is a little hard. I have, and I will post, I have templates that will show you that if you cut them out and you form them, they will make the 3 pyramids, and you can put those 3 together. And I was looking for, I thought I had one already made, but that is at Tech. And so, but you can make those, and I will post those templates on the website. So if I have any pyramid that's not, this is specifically a cube, but if I have any pyramid, so say I have a hexagonal pyramid or a triangular pyramid, which is also a platonic solid, right? If they're all equilateral triangles, it's a platonic solid. If I have one of those, then it's going to be the area of the base times the height of the pyramid. So that, and you're going to multiply it by 1/3, because each one of those, 1/3 of those will, 3 of those will make any kind of pyramid. So 3 triangular pyramids make 1 triangular prism, is what I'm trying to say. If I have a cone, again, 3 cones, actually 3 cones make a cylinder. And so, and it's the similar way that you would put together the 3 pyramids to make a cube in the previous thing. But again, if I want to find the volume of a cone, it is 1/3 the area of the base times the height. Remember, if I just did the area of the base times the height, that's going to give me a cylinder. If I want to do a cone, it's 1/3 of that, because 3 cones would make a cylinder. Okay? Again, sphere, the volume of the sphere comes from calculus, so you need to know it as 4/3 pi r cubed. And that's one of those that we will not ask you where that comes from unless it's just a you know, where do you get this formula? Well, you get this formula from calculus. Okay. Now, I'm going to work some examples, and I may, for the first couple, I may put them into the calculator and show you how to come up with the answers, but then I'm just going to talk through. I'm not going to go through every single calculation of how to put it into your calculator. That's something you should know how to do. And there are a couple, as time goes on, I don't want to make this video too long. And so I'm going to work a couple examples, and then I'm going to pause it, and I'll come back and work some more just to make it so it's not quite so long of a video. All right, let's look at, this is WebAssign question number 1. It is a right. So this angle right here is a right angle, and it is a triangular prism. And I want to find, I'm given that AB is 8 inches, so that's 8. I'm given that BC is 12 inches, and I'm given that AD is 3 feet. And I need to change that feet to inches, or I need to change the inches to feet. And so it's going to be easier to change this to inches, and that is 36 inches if I change it to inches. And you have to make sure that all your units agree. Okay, so make sure that all your units agree. And I want to find the surface area. So in order to find the surface area, I need to find AC. Well, how can I do that? I know that this is a right triangle. I'm given 8 and 12. And so in order to find AC, what I'm going to do is I'm going to use Pythagorean theorem. So 8 squared plus 12 squared equals AC squared. So 8 squared is 64, 12 squared is 144. So that's 80208, which is 14.4 inches. Okay, so this is 14.4 inches. Now to find the surface area, I need to find the area of the base plus the area of the sides. Now, these sides are all going to be different, so I have to find each one. So the surface area is going to be, the area of the base is 1/2 8 inches times 12 inches plus the area of the AB side is going to be 8 inches times 36 inches, and that's the AB side. Then I have plus the BC side is going to be 12 inches times 36 inches plus the AC side is going to be 14.4 inches times 36 inches. And so my surface area comes out to be, gotta find the calculator, 0.5 times 8 times 12 plus 8 times 36 plus 12 times 36 plus 14.4 times 36. So my surface area comes out to be 1286.4 inches squared. Now, I put, and that is not what I came up with on the sheet, and I know why. What did I miss? What did I forget to do? Right here, I forgot to multiply that by 2. So I'm going to go back in, and I'm going to go second equation, and that gives me back my equation, and I'm going to insert 2 times at the beginning of this because I forgot to multiply my 2 bases together. All right, when I do that, what I come up with is 1334.4. Okay, which is close to what the sheet says, and where I'm messing up is that I have rounding error on the AC length. Okay, so I have some rounding error here because I didn't round in the notes. Okay, so the answer's close. What I came up with in the notes is 1335.2, and so that's just a rounding error. Okay, now how do I find the volume? Okay, and I will tell you this, round your answer to one decimal place. In WebAssign, they're going to expect you to round your answer every time. And so that's where rounding error, make sure that if you're having problems with putting the answers into WebAssign that you're checking the rounding error. So you might try it unrounded, you then round it at the end, you might try rounding it at every step. If you're still, after you've tried all those possibilities and you're still not getting the correct answer, then please make sure to email your instructor. If I want to find the volume is going to be the area of the base times the height. Well, the area of the base is 1/2 8 inches times 12 inches times my height is 36 inches. And so that's going to give me the volume. I put it in here. I put 1/2 times 8 times 12 times 36. And that gives me that the volume is 1728 inches cubed. Now, notice again that I write each of these as inches, 8 inches, 12 inches, 36 inches. The reason I do that is so that at the end of the question, I have the units in the answer and I don't have to remember to write them down. That is my advice, is to always write it down. Now, it was given to me that AD was in feet. I may need to convert this to feet cubed from inches cubed. And so how do I do that? This is 1 foot is 12 inches. I have to do that 3 times because it's cubed. So that's going to be 1728 divided by 12 divided by, and I'm going to do this as parentheses 12 times 12 times 12, close parentheses, equals 1. So that gives me 1 foot cubed. Okay? That answers that question. On your test, on your homework, make sure that you look and check and see if the question says answer in feet, answer in inches, answer in kilometers, answer in centimeters. That way, if it doesn't say and all the units are the same, then you're going to use those units. But you just need to make sure that all the units are the same and that it doesn't tell you to put your answer in a different unit. Okay? Next, I have a pyramid. The base of the pyramid is a square. And so that tells me that this is 120 feet by 120 feet. With the height of the pyramid is 65. If I'm going to find the surface area, I need to find that slant height. If this height is 65, that means that this is 60 inches. Is 60 feet. Sorry, that's feet. So I need to find this slant right here by Pythagorean theorem. So L squared equals 60 squared plus 65 squared. And by doing that, that should be a squared, so it doesn't look like 2. By doing that, I come up with that L squared is 88.4590 feet. Okay? And I'm going to leave that for you to plug into your calculator and come up with the answer. The way that I would do it is if you have your calculator, I would do 60 squared plus 65 squared. And then I do second square root, second answer, and hit enter, and that tells me the answer. Okay? But I will leave you to go through all those steps just for time's sake. Now, if I want to find the surface area, it's going to be the area of the base plus 4 times the area of the face. So the surface area is going to be, the area of the base is 120 feet squared plus 4 times the area of that triangle part is going to be 1/2. The base is 120 feet times the slant height, which is 88.4590 feet. All right, and I'm multiplying that by 4. So I find that the surface area is 19707.5418 feet squared. And I'll leave that for you to plug into your calculator. The volume, this is a pyramid, so it's going to be 1/3 the area of the base times the height. So that's 1/3. The area of the base is 120 feet squared, and the height is 65 feet. So that gives me that the volume is going to be 312,000 feet cubed. Okay? Now I am using the worked out notes so that I don't have to go through and plug in all of the values. All right, now let's move on. The next is a cylinder, and it gives me that the units are in, the diameter is feet inches, 6 feet 6 inches, and the height is 11 feet 3 inches. I'm going to change these so that all the units are in inches. Okay? If I change them so that they're all in inches, then I don't have to worry about keeping number of feet and number of inches scared together. So this becomes 6 times 12 plus 6. So that's 78 inches. And this is 11 times 12 plus 3. Why am I using 12? Because there are 12 inches in a foot. So 11 times 12 plus 3 gives me 135 inches. All right, so I know that the diameter is 78 inches, but I really want the radius because I like to use radius. So 78 divided by 2 tells me that this is 39 inches is my R. And my height, my H, is going to be 135 inches. So how do I find the surface area? The surface area is going to be 2 times the area of the base plus, remember I cut that height open, and when I do that I'm going to have the height times 2 pi r for the lateral face. So now let's put all our base. The area of our base is pi r squared. So our surface area is going to be 2 pi times 39 inches squared plus 135 inches times 2 pi times 39 inches. Now I do realize that you could use diameter. I use pi r squared and 2 pi r. I don't ever change it to diameter times pi. To me, that's one more piece of knowledge that I don't want to have to memorize. Putting all these values in, using 3.14 as pi because the WebAssign likes to use pi equals 3.14. On your exam, I just as soon have pi in the answer. So we come up with our surface area is 42616.08 inches squared. Okay, to find our volume, we're going to have the area of the base times the height. Our base is pi r squared times our height, so that's pi times 39 inches squared times 135 inches. Tells us that our volume is going to be 644,751.9 inches cubed. All right, and again, I am leaving this to you to plug it in your calculator and come up with the answer. All right. Next, we have a sphere with radius 7 inches. What is the surface area? Well, the surface area of a sphere is 4 pi r squared. So our surface area is going to be 4 pi times 7 inches squared. And that gives us a surface area of, I would want your answer to be 196 pi inches squared. WebAssign would want your answer to be 615.44 inches squared. Right? The volume of a sphere is 4/3 pi r cubed. So that's 4/3 pi 7 inches cubed. Going through, the WebAssign answer would be 1436.0267 inches cubed, and you would round that into 2 decimal places, so you would get 1436.03. I would expect your answer to be 1372 divided by 3 pi inches cubed. So this is what I want on your test. All right? If a cylinder has the height is 12 feet and my radius is 3 feet, what is its surface area? The surface area of a cylinder is 2 times the area of the base plus 2 pi r h, because that's that rectangle that you unroll. So your 2 pi r is your length, h is your width. Your base is pi r squared. All right, so then what you get for your surface area is 2 pi times 3 feet squared plus 2 pi times 3 feet times 12 feet, which gives you an answer of, looking for the question, 90 pi feet. Squared is what I would expect. All right, multiplying that by 3.14, then you can come up with the WebAssign answer. The volume is going to be pi r squared h, because it's the area of the base times the number of slices, so times h. So you're going to get pi times 3 feet squared times 12 feet. So that gives you 9 times 12. Well, what's 9 times 12? 2 times 9 is 8. So you're going to get 108 pi feet cubed. Okay? Notice I did that not using 3.14. I did that without a calculator. You know that 3 squared is 9. You should be able to calculate 9 times 12 in your head if you don't know it already, which I don't. I just know how to multiply. 9 times 2 is 18. 9 times 1 is 9. Carry the 1 from before, so that gives me 108 pi feet cubed. You need to be able to do that in your head. You will not have a calculator as you walk around your classrooms teaching. If I know that the volume of a cylinder, that the volume is 400 meters cubed and the radius is 6 meters, what is the height? Well, the volume of a cylinder is pi r squared h, right? So I know that 400 meters cubed equals pi times 6 meters squared h. So that means that h equals 400 divided by 36 pi because 6 squared is 36 meters, and that's going to tell me what h is, and I find that h is 3.54 meters. Okay? Next, okay, I have a basic roof design. Find the total area of each roof shown. This is only part A. And so I want to find the area of the roof, and so that is this part right here, because they are flat, gable, hip, pyramid, hip. Find the total area of each roof shown, exclude the shaded part. So I'm only wanting to find this piece right here. The area of a rectangle is length times width, so that's going to be 16 feet times 6 feet, so the area is going to be 96 feet squared. Okay, but I have the back side, remember, because this is only one piece, I have the other side, so I'm going to multiply this by 2, and that gives me that my area of the non-shaded region, the total area, is going to be 192 feet squared. Okay? Alright, next we have a fish tank. I want to know how much water the fish tank will hold, so that is the volume. The volume is length times width times height. So the volume is going to be 60 centimeters by 30 centimeters by 40 centimeters. And so I get a total volume of 72,000 centimeters cubed. Okay? If I have 72,000 centimeters cubed over 1, I know that 1 liter is 1,000 centimeters cubed. Then that tells me that this is 72 liters of water. If a small tropical fish needs this much space for living, how many fish can live in the tank? I have 72,000 centimeters cubed. Each fish takes this much room, so I'm going to take 72,000, divide it by 1,500, and I come up with 48 fish. I can put 48 fish in the tank. And so you would need to write each of these sentences each of these answers in complete sentences to make sure that you explain what your answers are. All right. Number 35. Okay. I have a 15-step staircase, each made out of concrete. There are 3 of the steps are shown, but remember I have a total of 15. This is just 3. What is the volume of the 15-step staircase? What I'm going to do is I want to know how much concrete it's going to take to pour to make these 15 steps. Okay, well, the volume of a step, this is a triangular prism. So the volume of a step is going to be the area of the base, so that's 1/2 base times height times the height of the step, or the length of the step. So this h is the height of the triangle, and this is the height of the step, or the length of the step. So my volume is going to be 1/2 times 30 centimeters times 15 centimeters times the 90 centimeters that it's going to cost, the length of each one. And so then I'm going to get, so that volume right there for one step is 20,250 centimeters cubed. But how many steps do I have? So the total volume is going to be 15 times the volume. So that's 15 times 2, 250 centimeters cubed. So that tells me that the total volume is 303,750 centimeters cubed. So that's how much concrete it's going to take me to make these 15 steps. Now, another way that you could add on to this is you could say that each bag will make this much volume. Then you take each bag costs this much. So what's the cost of making these steps? That's just a way that you could further this question, okay? And in some class it is furthered. Okay, last question. Oops, no, we have one more after this. Second to last question. We have a cone. The diameter of this cone is 20 feet. The height of the cone is 12 feet. The tank is filled, so the height of the tank right here is 9 feet. All right, so if this is 12 feet and that's 9 feet, so how much is this part that's not filled? Is that 3 feet? All right, so how much liquid is in the tank? Well, the easiest way to do this is to find the volume of the big cone and subtract it from the volume of the part of the cone that's not, because this is a trapezoid, right? And so to find that volume is, trust me, a lot harder. So it's going to be easier to find the volume of the big cone and subtract from it the little volume. So the volume of the big is going to be pi r squared h times 1/3, because this is a cone. So it's 1/3 pi. Our radius is 10 feet. Times our height is 12 feet. So we find the volume of the big to be 40 pi feet cubed. Okay. Now, what do I need to know what do I need to know in order to find the volume of the small cone? So in order to find the volume of the small cone, I need to find the radius of this small circle, right? Well, remember that these are proportional, right? They're similar. Remember the triangle with its split? So if I have, this is 20, right? And I know that that the height is 12 and that this is 3, right? 3 is to 12 as x is to 20. Okay? Then I can do that. So this is 1 as to 4 as x is to 20. Find my LCD. My LCD is 20. So 5 equals x, right? If I multiply this side right here by 5 over 5, then what I get is 5 over 20. Well, that means that if these two fractions have the same denominator, then the numerators have to be the same, so x has to be 5. Okay? So I have that x is 5, so that radius is 5. So the volume of the small cone is going to be 1/3 pi r squared h. So that's 1/3 pi. My radius is 5 feet squared times the height is 3 feet. Okay? Multiplying that out, I get that the volume of the small is 25 pi feet cubed. Right? Now I want to find the volume of the shaded is going to be the volume of the big minus the volume of the small. So the volume of the shaded equals 40 pi feet cubed minus 25 pi feet cubed. So the volume of the shaded equals 15 pi feet cubed. And that's also the water. And you would multiply that by 3.14 and come out with your answer. Okay? Now, the last question